In this video, we will learn the basic theory of operation of the boost converter, and I will show you how to build a simple prototype. You will need the following materials: 10 meters of magnet wire, metal screw, diode, capacitor, and a push-button switch. Inductors are at the heart of the boost converter, so let's first check how they work. When a battery is connected to the inductor, a current is established in the circuit and a magnetic field is created around the inductor. If we disconnect the battery, the magnetic field collapses and induces a voltage in the circuit. This voltage can be higher than the applied voltage, depending on the number of turns of the inductor. This is the basic circuit for the boost converter. When we close the switch, the current flows through the inductor and a magnetic field is created. When we open the switch, the magnetic field collapses. But now the switch is open and the induced current has to flow through the diode and the capacitor, and the capacitor charges. Every time we close and open the switch, we are pumping charge into the capacitor and its voltage starts to rise. The final voltage of the capacitor and of the converter will depend on the voltage of the battery and on the characteristics of the inductor. Here we have our circuit. This is the inductor. It is made with a metal screw and 250 turns of magnet wire. This is size 29, but you can use any size that is close to 29. A switch. This is the diode. Any rectifier diode will work. And I am using a capacitor of 10 microfarads at 200 volts. We will connect the positive here and the negative. And at the output, in the terminals of the capacitor, we should get a higher voltage than that we put at the input. Okay, let's try our circuit. I'm going to use a 6-volt battery. Let me connect. We can see in the meter the voltage of the battery, and I'm going to push the switch. We can see how the voltage goes up, and we can get up to some 20 volts. For example, we can use as inductor the coil of a relay. In this relay, these 2 points are the coil. And let's connect to our circuit to see if it works. We can see how the voltage goes up to some 25 volts. Let's try with a transformer. I'm going to use the primary coil as inductor. And we get more than 60 volts. Let me disconnect and discharge the capacitor. And now let's use the secondary coil. Let's see. We get even a higher voltage. It's 150 volts approximately. Of course, in a real converter, we do not use a switch, but instead we use a transistor or a MOSFET in order to do the commutation much more rapidly and efficiently.